So this is a MCQ type problem where we are given that x, y and z are in a GP, means geometric progress, and tan inverse x and tan inverse y, tan inverse z are in AP. Then what is the correct option? So we have to find out this. So first of all, look at the let's look at into the definition of AP and GP. So since since we know if A, B and C are three quantities that are in AP, so we can simply say that twice of B is equal to A plus C. So this property we're going to apply over here, because we know that tan inverse x, tan inverse y and tan inverse z, all three quantities, they are the inverse trigonometric ratio and they are in AP. So we can simply say 2 tan inverse y is equal to tan inverse x plus tan inverse z. Okay, so now here we can use our trigonometric formula of tan A plus B, which is equal to tan A plus tan B upon 1 minus tan A tan B. So here x and z, x is equal to tan A and z is equal to tan B. So what we can say that tan inverse x plus tan inverse z, which stands for A and B respectively, is equal to, when we transfer this quantity in the right hand side, we'll get tan inverse in right hand, and tan A is nothing but x and tan B is z, and same is in denominator. So this is the expression what we get. So we can replace this tan inverse x plus tan inverse z by this expression. We can substitute this value and can get a new expression, which is tan inverse x plus z upon 1 minus xz. Okay, fine. And since we know that 2 tan inverse y, we can also transform this, because we know that tan 2 theta would be equal to 2 tan theta minus 1 minus tan square theta. Okay, so since we know that tan inverse y is theta, if we assume this, then we can simply say tan 2 tan inverse y is equal to 2 we can evaluate the value of tan theta by this equation, which is nothing but the y. So we can substitute the value of tan theta, which is y, and 1 minus y square over here in denominator, and this is nothing but the tan inverse of 2y upon 1 minus y square. And now we can substitute this value in above equation over here, and we'll get a new expression, which is tan inverse 2y upon 1 minus y square is equal to, in right hand side we have another tan inverse expression, which is x plus z upon 1 minus xz. Tan inverse x plus z upon 1 minus xz. By comparing the two sides, we can simply say that 2y upon 1 minus y square is equal to x plus z upon 1 minus xz. And here comes the second piece of information that is given in our problem, which is that xy which tells that x, y and z are in GP. So we have to use this information, that x, y and z are in GP. So what we can say, that y square is equal to x into z. This is a very basic property of GP. So we know the value of y square. So since we have the xz part in the denominator of right hand side, so we can simply substitute its value y square over here. So what we know, that 2y upon 1 minus y square is equal to x plus z upon 1 minus y square. And now we get a expression where the denominator of two sides are same. But before cancelling them out, you have to consider the one thing, that if y is equal to 1 or minus 1, then in that case we cannot cancel them out, because the division by 0, any quantity cannot be divided by 0. Division of 0 is undefined, we don't know. So if you want to cancel them out, then you have to put the restriction over the value of y that it could not be equal to 1 or minus 1. So first condition that we get, y cannot be equal to plus or minus 1. And now after putting this condition, you can simply cancel out and get 2y is equal to x plus z. And since you know that y and z are in GP, so we can also say that this condition also holds true for x, y and z. So y square is equal to x into z. So now we have two equations, and after solving this, what you get the value is important. So let's try to solve them. First, if you take the first equation and square the both sides, we get the, oops, this must be z, yeah, x plus z. So we get the 4y square in the left hand side, and we can expand the a plus b whole square formula over here, and we know that y square is equal to x z. So we can just put the value over here, z square plus 2xz. We can solve this expression, and we finally get this, which simply implies that x minus z is equal to 0 and x is equal to z. And after substituting this in one of these two equations, we simply can obtain that x is equal to z is equal to y. So this is our second condition that is important. The first one was this, y cannot be equal to plus or minus 1, and the second thing that x, y, z are both AP and GP. Then it simply implies that these three quantities are equal. So we can simply say that our first option is correct, where we are given that x is equal to y is equal to z, or y is equal to plus or minus 1. It simply means that both conditions may not simultaneously correct. If you are taking y is equal to plus or minus 1, then you cannot proceed further from this point.